Evaluating AI interaction design requires a comprehensive approach that combines both qualitative and quantitative research methods in order to capture the complexity and evolving nature of AI-driven systems. Traditional usability evaluation techniques remain important, but they are no longer sufficient on their own because AI systems adapt, learn, and change behavior over time. Evaluation methods must account for both immediate user interactions and long-term user experiences. Qualitative methods play a crucial role in understanding how users perceive and interpret AI systems. Techniques such as user interviews, contextual inquiries, think-aloud protocols, and observational studies help uncover user expectations, mental models, and emotional responses. These methods are particularly valuable for identifying issues related to trust, transparency, and perceived control, which are difficult to measure using numerical data alone. Qualitative insights also help designers understand why users behave in certain ways when interacting with AI-driven features. Quantitative methods complement qualitative research by providing measurable and comparable data. Traditional usability testing can be used to assess task completion rates, time on task, and error frequency. In AI systems, these methods are often extended through longitudinal studies that track user behavior over extended periods of time. Longitudinal evaluation is especially important because AI performance and user perception may change as the system learns and adapts. Additional evaluation techniques such as A/B testing and behavioral analytics are commonly used to compare different interaction designs and measure their impact on user behavior. These methods allow designers to test variations in explanations, feedback mechanisms, or recommendation presentation, and assess which approaches lead to better outcomes. Behavioral analytics can reveal patterns in user engagement, reliance on AI recommendations, and recovery from system errors. Key evaluation metrics in AI interaction design may include task success rates, user satisfaction, perceived trust, confidence in system outputs, and effectiveness of error recovery. Unlike static software, AI systems require continuous evaluation because the behavior may change as models are updated or new data is introduced. Ongoing monitoring and iterative refinement ensure that interaction design remains aligned with user needs and expectations over time. Continuous evaluation is therefore essential for maintaining usability, trust, and overall system effectiveness in AI-driven environments. AI interaction design faces a wide range of challenges that arise from both the technical nature of artificial intelligence and the limitations of human understanding. One of the most significant challenges is unpredictable system behavior. Because many AI systems rely on machine learning models that adapt over time, their outputs may change in ways that are not immediately apparent to users or even to designers. This unpredictability makes it difficult to design interaction that remain consistent and understandable, and it can lead to confusion or loss of trust when system behavior does not match user expectations. Data bias represents another major challenge in AI interaction design. AI systems learn from data that may contain historical, cultural, or structural biases, which can influence system outputs and user experiences. Even when designers aim to create fair and neutral interactions, biased data can lead to unfair recommendations or decisions. Interaction designers must therefore work closely with technical teams to identify potential bias and design interfaces that allow users to recognize, question, and respond to biased outcomes. Technical constraints also limit what interaction designers can achieve. Designers often have little direct control over underlying algorithms, model architectures, or training data. This can restrict the level of transparency or explainability that can be realistically provided to users. As a result, close collaboration with data scientists, engineers, and product teams becomes essential. Effective AI interaction design depends on interdisciplinary cooperation to align technical capabilities with user needs and design goals. User misunderstanding is another persistent challenge. Many users have limited knowledge of how AI systems work and may hold unrealistic assumptions about their intelligence or accuracy. This can lead to over-reliance, misuse, or rejection of AI systems. Designers must find ways to educate users without overwhelming them, helping them develop accurate mental models while maintaining a smooth and intuitive experience. One of the most difficult challenges is communicating uncertainty without reducing usability. AI systems often produce probabilistic outputs rather than definitive answers. But presenting uncertainty can make interfaces feel complex or less reliable. Designers must balance honesty and clarity with simplicity and confidence. Poor communication of uncertainty can either erode trust or create false confidence. Addressing this challenge requires careful design of explanations, feedback, and visual cues that support informed decision-making while preserving a positive user experience. Future developments in AI interaction design are expected to significantly expand the ways in which humans engage with intelligent systems, introducing new opportunities as well as complex challenges. One of the most important trends is the growth of multimodal interaction. AI systems are increasingly capable of processing and responding to multiple input and output modes, such as text, voice, gesture, facial expression, and visual context. This shift allows interactions to feel more natural and fluid, but it also increases design complexity. Designers must ensure that different interaction modes are well coordinated, consistent, and accessible so that users can move seamlessly between them without confusion or loss of control. Another major development is the rise of emotion-aware systems. Advances in affective computing enable AI systems to detect and respond to emotional cues, such as tone of voice, facial expressions, or behavioral patterns. While this has the potential to create more empathetic and supportive user experiences, it also raises significant ethical and design challenges. Designers must carefully consider accuracy, privacy, and consent, as well as the risks of misinterpretation. Interaction design will need to balance emotional responsiveness with transparency and user comfort, ensuring that emotion-aware features enhance rather than undermine trust. Adaptive personalization is also expected to become more sophisticated. Future AI systems will increasingly tailor content, recommendations, and interaction styles to individual users in real time. While personalization can improve relevance and efficiency, it can also make system behavior less predictable. Designers must ensure that personalization does not isolate users, reinforce bias, or reduce user autonomy. Providing users with visibility and control over personalization settings will be essential for maintaining trust and understanding. In parallel, increased regulatory oversight is likely to shape the future of AI interaction design. Governments and institutions are developing regulations related to data protection, transparency, accountability, and ethical AI use. Designers will need to incorporate regulatory requirements directly into interaction design, ensuring that systems clearly communicate rights, responsibilities, and limitations. Compliance will no longer be only a legal concern, but a core design challenge. As AI systems become more autonomous, interaction designers will face the task of preserving human agency while allowing systems to act independently. Designers must define clear boundaries between human and machine decision-making and create interactions that support collaboration rather than replacement. Advances in explainable AI and human-centered AI research are expected to play a critical role in shaping these new interaction paradigms, enabling users to understand, trust, and effectively work with increasingly intelligent and autonomous systems. AI interaction design is a complex and continuously evolving discipline that brings together technology, design, psychology, ethics, and human-centered thinking. It operates at the intersection of advanced computational systems and human experience, focusing on how people understand, use, and relate to intelligent technologies. As AI systems grow more capable and autonomous, interaction design becomes essential for translating complex machine behavior into experiences that humans can comprehend and trust. Effective AI interaction design ensures that systems are not only technically functional, but also understandable and meaningful to users. Functionality alone is not sufficient when systems make predictions, recommendations, or decisions that affect human lives. Users need to understand how AI systems operate, what their limitations are, and how their outputs should be interpreted. Clear interaction design supports accurate mental models, reduces confusion, and prevents both blind reliance and unnecessary skepticism. Trust is another central outcome of well-designed AI interactions. Trust does not emerge simply from high performance or advanced algorithms, but from consistent, transparent, and respectful communication between the system and the user. Interaction design shapes how confidence, uncertainty, and feedback are presented, allowing users to develop realistic expectations of system capabilities. Over time, this balanced trust enables more effective collaboration between humans and AI systems. Alignment with human values is also a defining goal of AI interaction design. Design choices influence fairness, accessibility, autonomy, and ethical responsibility. By considering psychological and social factors, designers can ensure that AI systems support human dignity, inclusivity, and well-being rather than undermining them. Ethical considerations must be embedded into the design process to prevent harm and promote responsible use. As AI continues to integrate into everyday life across domains such as healthcare, education, finance, and communication, the importance of interaction design will only increase. AI systems will increasingly shape how decisions are made and how information is accessed. In this context, AI interaction design plays a critical role in shaping responsible and meaningful human-AI relationships, ensuring that technological progress remains centered on human needs, understanding, and values.